Okay, this is actually very simple. Calculating the mean and the standard deviation. I guess hopefully you know what the standard deviation is. Right now we won't talk about it. It's just like another calculation, like calculating the mean. So anyway, the mean, you have a vector x, and you can calculate the mean of it this way. We know that. And you can also calculate the standard deviation, which is another function, and that's like this. Then an alternative way to do it, the kind of long way, he says, is first you calculate the length of x and call it n. So that's in this case going to be 8. Then you're going to take the sum of x and divide it by n. That's going to give you the mean. And then he does some other calculations here. He takes x minus its mean, squares those, and then takes the sum, and that's called the corrected sum of squares. And he goes into like, what does it mean here? So here you get you get the vector, and then you get the length. Sorry, you get the mean is 4.5, and the length is we know what the length is. So you take x minus the mean. That takes that's 1 minus 4.5, 2 minus 4.5, 3 minus 4.5, right? And then you get these numbers, and then you square them. This means square it. So you square each of these numbers, and you get these numbers. And then you add all those numbers, and that's what we did. And then here, he takes the square root of that and divides it by n minus 1. So this is a kind of statistical thing that's done sometimes. Maybe we'll be able to get into it, maybe we won't. Anyway, here's the results. Okay, let's just read about this. The scale function, I mentioned it in the last video, standardizes the specific columns of a matrix or data frame to a mean of 0 and standard deviation of 1. So we said that we wanted to do something like that. We wanted all the columns to have sort of the same center and sort of the same spread of the data. Now, I don't know if you know what I mean by the spread of the data, but if you took statistics with me, you should know. And if you took statistics with somebody else, I hope you know. But that's what the standard deviation is. So if you want to know more, please don't hesitate to ask me in class, and I'll give a more detailed explanation. And I'd be happy to give it to the whole class. So if anybody wants to ask me, please go ahead. Okay, so anyway, so we can do that here, scale the data. To standardize each column to an arbitrary mean instead of specifically to 0, but to an arbitrary mean, you can use code similar to that one. I see, code similar to, so you could multiply by SD and add M. So you'd first, this will standardize it to a center of 0 and spread of 1. Then if you multiply it by some other number, it's going to have a spread of more than 1, or it's going to have a spread of SD. And then if you add M, it's not going to be centered at 0 anymore. It's going to be centered at M. Okay, he also says if you try and use this on non-numeric data, you'll get an error. And then he says you can transform this. You can, let's see, you can use the transform function. This is if to standardize a specific column rather than the entire matrix or the entire data frame. You can use this kind of code. So you use transform, which we've seen before. You can look it up again on your data, and you specifically want to transform just one variable. And so you just do that, and you scale the variable. And here we're multiplying by 10, so it's going to have a standard deviation of 10, and we're going to move the mean from 0 to 50. And this is just going to be done for my var, or just in other words for a single variable. So anyway, you can do different kinds of scaling here. but remember the scale function.